Hi, this is XTAL. Today we're going to build a bitmap-style visual effect in TouchDesigner, working directly with pixel-based imagery. A bitmap is a two-dimensional image format where each pixel holds color information. By tapping into that structure, we'll create digital textures with a raw graphic feel. Let's walk through it step by step. First, drop a movie file in Node to bring in the video and load the file you want to apply the bitmap effect to. Next, connect a transform node, set the background color to white, and enable the background color. By enabling the background color, it ensures that the effect is more pronounced and provides a solid base for applying further adjustments or effects. Next, add a null node to organize the output flow. This acts as a clean anchor point for adding more effects or keeping your network structure tidy. Connect a resolution node and turn it on. This allows you to force the output resolution, which helps emphasize the pixelated bitmap style more clearly. Next, connect a monochrome node. This removes color information and converts the image into black and white pixels, enhancing the graphic and minimal look of the bitmap style. To refine the depth and contrast of the bitmap effect, we connect a level node. To isolate the blue channel and create a cooler tone in the bitmap style, we connect a channel mix node and set the red and green values to 0. To apply a ramp texture and bring in stylized color and graphic gradients to the bitmap effect, we drop in a composite node. Connect ramp 1 and ramp 2 nodes to the composite node and set their colors to red and green respectively. Change the type of the green ramp to vertical. This adjusts the gradient flow vertically, giving a different color transition effect. Drop a slider node and reset the value to adjust the intensity or other parameters of the effect in real time. Connect a math node. This node allows for precise mathematical operations on values, giving you finer control over the intensity and details of the bitmap effect. Bring in an info node and enter null1 in the operator field. Then input res_x and res_y in the scope. This setup helps accurately track and control the resolution of the bitmap effect. Next, drop a math2 node and connect it to math1 using CHOP reference. This allows math2 to reference the values of math1, ensuring consistent calculations. Next, connect a null node. Reference the resolution of the null node to the previously set resolution node using CHOP reference. Next, connect a math3 node. Change the combine option in the math node to device. This setting combines multiple values into a single device, allowing for more efficient control over various parameters. Next, apply the resolution of the null node to ramp 1 and ramp 2, ensuring they match in size. This ensures all elements maintain the same resolution and size, providing consistent visuals. Change the operation of the composite node to add. Next, connect the null node and the top to node in sequence to the composite node. This ensures the output from the null node is correctly converted through the top to node for the final output. Next, connect a shuffle chop. This node allows for rearranging or mixing channels to fine-tune the details of the bitmap effect. To select a specific channel and extract or use only the desired value for further operations, we connect a select chop and enter B in the channel name field. Connect a replace chop to swap the selected value with another, allowing you to fine-tune the effect. The replace chop swaps specific values, while the limit node constrains the values to a specific range, ensuring the bitmap effect stays within the desired boundaries. This approach leads to a more refined and predictable bitmap output. Connect select 2 to the limit node, then change the channel name to G. Connect a math node and change the combine chops option to multiply. This setting multiplies values between channels, allowing you to adjust the intensity or effect of the bitmap. Connect the math node to the replace chop to apply the final computed values to the bitmap effect. Connect Math 1 to Math 4 to combine data from both channels and create a more refined bitmap output. Now connect a null chop to the replace node and rename it to instance. This naming convention helps streamline your workflow when using it later for instancing purposes. Drop in a render top to visualize your 3D scene. This node compiles the camera, lights, and geometry to generate the final output image. Drop in a circle SOP to generate the dotted pattern for the bitmap effect. This SOP creates circular instances that resemble pixel dots, forming the core visual of the bitmap look. Connect a null to the circle. Next, bring in the geocomp, camera comp, and constant mat to build the foundation of your 3D scene. These components work together to render your instances properly and are essential for accurate visual output. Enter instance in the Geo's instance op and connect the null you created earlier. This allows Geo to reference the instances from the null, rendering each point for the bitmap effect. In the Geo instance, set R for translate X, G for translate Y, and B for scale X, Y, Z. This is done to map the values of each channel to the X, Y, and Z axis, controlling the position and scale in 3D space. R corresponds to the red channel for controlling translation on the X-axis, G for the green channel on the Y-axis, and B for the blue channel to adjust scaling across all 3 axes. This setup allows precise control over the position and size of each instance in the bitmap effect. Reset the resolution of the render to match the values from the info chop. This ensures that the rendered image is outputted at the correct resolution, matching the original media. By using the resolution values from the info chop, the size and aspect ratio of the rendered visual will align with the original content. Adjust the from range and to range values in Math 1. This step is necessary to transform the input values into the desired output range. The from range defines the minimum and maximum values of the input, while the to range sets the output range, allowing for proper scaling of the data and achieving visually accurate results. Adjust the scale of the cam dot. This step is necessary to control the camera's viewpoint and perspective within the 3D scene. By changing the camera scale, you can alter the distance and size of the camera, which helps achieve the desired visual effect. This adjustment provides the appropriate perspective for the scene and enhances the focus and depth of the visual output. Use the overtop node and constant top node to combine the background color with the bitmap effects color. The overtop node is used to layer two images, while the constant top node allows you to set a solid background color. By combining these two nodes, you can seamlessly blend the bitmap effects colors with the background, enhancing the depth and contrast of the visual. This process results in a more dynamic and refined color composition in the final output. By using the level node, you can experiment with a broader range of colors. The level node is useful for adjusting the range and contrast of colors, giving you finer control over the color data. This allows you to manipulate brightness and contrast or emphasize specific colors, enabling you to transform the color palette of the bitmap effect. Through experimentation, you can create more unique and creative visual outcomes. Connect the out and movie file in out nodes. This step is necessary for final output and saving your visual. The out node is responsible for outputting the final result from TouchDesigner, while the movie file in out node allows for importing and saving videos. Use the constant node to adjust the color to your desired style. By utilizing this node, you can create the color palette you want and adjust the mood and style of the visual to suit your preferences. Experimenting with different colors allows you to create more unique and personalized results. Let's add a background to the level node and adjust it. By setting the background and using the level node to fine-tune the colors and contrast, you can balance the overall visual and create richer, more dynamic effects. Finally, fine-tune the values of level 1 to adjust the bitmap effect in various ways. You can create different results, from larger dot effects to finer, more subtle textures, giving you flexibility to experiment and achieve the desired look. Through today's tutorial, we've explored how to use the bitmap effect as a tool to experiment with our own creative expression. But the key takeaway isn't just the final result, it's the journey of understanding ourselves through the process and ultimately discovering our own visual language. Creativity finds its place through continuous experimentation and challenges, and it's in this journey that we uncover our true essence. I hope the techniques and ideas shared today bring you one step closer to your creative goals. Keep experimenting and pushing your boundaries and discover the true power of creativity. Don't forget to subscribe so you can easily access my content, and the effect file we created today is available on my Patreon. Thank you for your support, and I'll see you next time.